So we're going to do square roots, okay? And square roots, one way to think of it is in their book, they'll show you this with area of squares, okay? This is one way. So we have two different squares here, and we're going to make a couple more, okay? Now, square root is similar to a power. It's essentially the opposite of the power of 2. So we know that 1 to the power of 2, what will that equal? 1, that's right. And all it means is 1 times itself, which is the base of the exponent, right? And we multiply it by itself by the number on the exponent itself. So we multiply 1, the base, times itself twice. We get 1 times 1 is 1. So we've proven that, okay? Now, the reverse of that would be if somebody were to have asked me what the square root of the number 1 was. The square root is the opposite. We're at the answer, and we're looking for the base. So what number times itself twice equals 1? 1, that's right. Square root of 1 is 1. 1 times 1 is 1. And a way to look at this is if we had area of these objects, these squares here. So if I had to find the area of this square, you guys can tell that this is 1 unit by 1 unit, right? So what would the area of this be?
1 centimeter square.
Yeah, so the area is equal to, we're just going to say 1 centimeter. And then it's 1 centimeter squared, that's right. Now, if they had given me just the area, so they had told me that the area of this is 1 centimeter, how would have I found one of the lengths? Do you know? If it was a square, what I would need to do is I would need to square root it, okay? So we have 1 centimeter, or let's just use it as the number 1 right now. If we were to do the square root of that number, 1, and I had to find the lengths of it, I know the square root of 1 is just 1. It's a little confusing, we're only working with the number 1 to start, okay? So there's a bit of an idea about 1. Let's go on to our next numbers, okay? So this time we're going to start at the box. How long is the width of this box?
2 centimeters.
Yeah, and how high is the length?
2
2
centimeters.
centimeters, right. Now, if we had to find the area of this, what would the area of this be?
4 centimeters square.
Yeah, we know the area is 4 centimeters squared, right? And we can look at that by counting this. There are 4 boxes, 1, 2, 3, 4, right? So we know it's 4 centimeters squared. Now, if I had to find the length of 4, so let's start in reverse of what we did before. I'm going to look for the square root of the number 4. What would the square root of the number 4 be? 2, that's right. It's essentially what these lengths are, okay? Now, what you're going to notice with square roots, to have whole numbers as the square root, we have to have, if you were to draw a diagram of it, it actually has to create a square. And we can prove what we just did before. I'll quickly do it. Square root of 1 is 1. Square root of 4 is 2. So we just proved those on the calculator, okay? So what we're going to do next is we're going to try a number. So let's extend this page a little. I'm going to try the number 6, okay? Sorry, not 6. Let's try the number 9. I'm going to try the number 9. We're going to look for a square root of the number 9. Now, can you think of what the square root of a number 9 would be? Yeah, that's right. We know that 3 times 3 will get to 9. And let's think of it if we were to make a square. Could I make a square? Or how would it look if I needed to? How long would the length of the square have to be?
3 centimeters.
Okay, and how long would the width?
3 centimeters.
Good. And if you notice, we make a perfect square if we go 3 by 3 in the square. Right? When we go 3 by 3, we get a total of 9. So we know we can find a square root of this. Okay. Let's talk about another number. I'm going to go to another page here quickly. what if I had the number 6? Let's try to make a square out of it. How can I make a square out of 6? Or what kind of four-sided shape? What would the lengths and widths be? Three, yeah, you're right. That would be the closest using whole numbers we could get. So, now here's a tricky question. Is there a square root to this 6 that's a whole number? Do you know what I mean by a whole number? That's not a decimal. Okay? So, does this look like it's going to have a square root, this? Are the lengths and the width the same? No. I can't really make a square out of that. If I were to move this box over to here, we still wouldn't have a square. And if I move this one over, well, I'm still looking at a 3 by 2. I still don't have a square with this shape. So there's not a whole number square root. Now, technically, if I put it in a calculator, it will give me a number. 6 square root, 2.4, will give a very, very long decimal. But we don't want to be working with decimals. We want to work with just whole numbers, okay? So what I want to do now is we already discovered with our square roots, this is going to be a quick list of square roots, okay? We knew that the square root of the number 1 is equal to 1. Square root of the number 2, sorry, thinking opposite, of 4 was 2. You know what I'm going to do. Okay, and we found out the square root of the number 9 was what number? 3. What could we get another square root of? Let's think of the next number along. I'm going to try to make a little list here. Up from 9. What would the next number be as a square root? 14? What would the square root of 14 be?
7.
What's 7 times 7?
Oh,
That's alright.
16.
16. What would the square root of 16 be?
4.
4. I want you guys to look at something. If you notice, we're going up 1.
1 and 2.
And how can I go from the answers to the square roots? If I did what to them? I could divide, but what's a quick way? If I know my next number, what's the next number we're going to be looking for, first of all, as an answer?
5.
5, that's right. How can I find the square root from this now?
You just multiply 5 times 5.
Yeah, so I put it to the power of 2, right? So what will the next square root be that's in this list here?
25.
Hey, good. What about the next one?
Oh, you put 26.
26?
No, you put 26.
Oh, sorry, I put 26. It's 25.
36.
Good. And what would the square root of 36 be?
6.
Great. Alright, let's keep going on this list. Let's see if we can't make a pretty decent list here. What would next be?
49.
Good. And the square root of that would be?
7.
Alright.
64.
Mm-hmm.
And the square root of 64 is 8.
Great.
And 81.
Mm-hmm.
Square root is 9.
Mm-hmm.
And 100.
Mm-hmm.
And the square root is 10.
Mm-hmm.
And 121.
Yeah, good.
And the square root is 11.
Mm-hmm.
144.
That's good.
The square root is 12.
Good. Alright, we'll leave it at 12 for now. So we have a pretty good list. Okay. This is what we covered. Went over the squares and how we can make squares. So if you quickly look also, the next number I could have used if we were going by 16, right? I could have made a square that was about 4 by 4. I should leave it there. It's a little slow because there's so much going on right now. But if you notice, this is a 4 by 4 square. So if I leave it at that, we know the square, our area of that would be 16. And if I needed to find the square root, this is 4 by 4. know the area is 16, right? And in other words, the square root of 16 is the number 4. And we could do that with every number we found on the other page. Does that make sense?